Good afternoon. Welcome to Researh Network. Friend, as you know, we have scheduled a number of lecture on the use of statistics in the research method, and we have covered large many statistical tools. And in a series of our lecture on statistical, today we will discuss binomial and chi-square methods. And for discussion on this very topic, we have in the studio Dr. S.K. Pandey. He is presently teaching at Research School of Management, and his area of expertise is research method. So I hope his knowledge and experience will help us to understand this topic in a new way. So on your behalf, I welcome Dr. Pandey for the research lecture. Welcome, sir.
Thank you. Friends, this is the last lecture in the series of lectures on statistics and its application in research methods. We found that maybe the statistical part in the lectures was more than the research methodology, and since this was the last lecture, it was felt that if we can integrate the entire learning of the 4 lectures into the last lecture. So not only talking in bits and pieces on chi-square and binomial, we would like to take the entire process of research method from the problem identification to solving and interpreting the statistical output. So today we will take a problem and then apply the various steps of the research methods into it, and then we will try to adopt the approach, and in the end come to some analysis and conclude based on those analysis. So we will follow the entire structure of research process, and will take a real problem which is being faced by one of the industries. So if you see, the agenda for today is we will understand the background to the problem, how did that problem arrive. Then we will talk about the exact identification of the problem. Then we will talk about converting that management problem into a research problem, because management problem has to be converted into a research problem to be able to know what exactly the data requirements and other things are. Then we will make certain hypothesis. Then we will collect the data, code the data, and in the second last step we will apply chi-square or binomial or some other non-parametric methods, and then based on it interpret the results. So if you see, then you will find that the entire process of research will be followed in today's lecture, and we will try to include statistics in the end only to analyze the data that we have collected. Friends, if you see, you would be able to recognize this. This is called as VISI cooler, although it is a fridge or a refrigerator, but it is called VISI cooler in the retailer parlance. And this refrigerator is often seen at various kirana stores. This holds various cold drinks, if you can see, and the best part of it is that it is transparent, and the contents of this refrigerator are visible even from a distance. The entire purpose of this VISI cooler is to actually attract people. As the summers are going to come, we often feel thirsty, and the moment we are passing by any of the retailers and if we see this VISI cooler, often we feel the need to have a cold drink, and immediately there is an impulse purchase. So impulse buying behavior is one of the very important topics that we study in marketing, and our today's lecture and problem will be dealing with this impulse buying behavior. A lot of studies have taken place in this regard, and it has been found out that impulse buying behavior is triggered in this type of in low involvement products by having a good display. So companies try to have a better display through these VISI coolers to attract the passers-by, and also at the same time this cold drinks are a low involvement product. By low involvement we mean that we don't think much because the price is very less and the other things are very less. So we don't often think much before going for a purchase, and the brand loyalty is very less. So suppose somebody likes Pepsi and goes to a retailer and asks for a Pepsi. If Pepsi is not available, it is more than likely that the customer will not go to the next shop and will buy something else other than Pepsi. So companies are trying hard to display their products uh, in a proper manner, especially in this type of scenario where the competition is very large and customer is not very loyal, so that they can attract customers. Now we will talk about a little bit about the problem being faced by this industry. As I mentioned, this industry is fiercely competitive. In fact, it is so competitive that cola companies, often there are cases and they are called as cola wars, because it is no less than a war. I am sure everyone is aware that whenever there is a new advertising campaign by Pepsi, Coca-Cola will often come with a counter campaign, and vice versa also. And in most of these events like World Cups, etc., we have often seen that the advertisements are very large in number, and they are usually aimed at negating the advertising of the opponents. So competition is very intense in this market. This is the entire crux of the situation being faced by cola companies. Cola companies often spend huge sum on advertising and try to outpace their other competitors. I am reminded of a campaign in one of the World Cups where one of the cola giant came up with the advertising campaign. We said that the official sponsor of the World Cup team, and the other competitor came immediately after that with an advertising campaign which indicated nothing official about it, was their slogan. So as we are trying to understand them, we find that these companies are spending crores and crores of rupees on advertisement to attract the customers, and the war is very intense. One of the means that they adopt now to attract customers, apart from advertising, these companies try to do a lot of other things which are included in sales promotion. They try to get into exclusive contracts with the retailers. You may often encounter a shop which will keep only either a Pepsi drinks or only Coca-Cola drinks, because the cola company would have entered into an exclusive agreement with this retailer that he will sell only their drinks. In such a scenario, mostly the customer will go for that product which is available rather than going to a next shop. Then many a times the companies also try to attract the retailers. If they cannot get into an exclusive agreement with the retailer, they try to push their products by giving a little higher margin to the retailers, and also trying to give free gifts and sometimes giving these VISI coolers. So many of the companies have given free VISI coolers to the retailers with this stipulation that the retailer will follow certain things as mentioned in the contract. So this VISI cooler is given free of cost to the retailer, and there are certain things which the retailer is expected to do. For example, the first and the foremost which the company expects is that the retailer will only keep their company product in the VISI cooler, and not any of the competitors or even any of the non-competing companies, because the VISI cooler has been given free to the retailer. The company expects that the retailer will only keep their products and nobody else's in that VISI cooler. Then there are other expectations, like the VISI cooler should be kept at a very good location so that it is visible. The name itself is VISI. So if it is not visible and is kept at a place where it is not visible, then the entire purpose of giving the VISI cooler is defeated. So the company usually want that the VISI cooler should be kept outside the shop, so that even when the customer is passing by just looking at the shop, they will be able to see the VISI cooler and will trigger the impulse buying behavior. However, at times this is not possible. So the second best location that the company expects is just inside the counter. So although then it is not visible to a passerby, but the moment this consumer comes to the shop and reaches the counter, he is able to distinctly see what is there in the VISI cooler. The third and the worst location is somewhere inside the shop, where even the counter person is even a consumer at the counter is not able to see. So these are the various things that the company wants, that the VISI cooler should keep only their company products, and then it should be at a very good location. There are other things also in this regard. For example, the company expects that the person will, or that the retailer will keep the VISI cooler properly illuminated. Illuminated means that usually the VISI cooler contents will be visible to the person outside, which means that proper lighting should be there. Usually the VISI cooler is provided with bulbs and tube lights inside, so that the products are highlighted, but they have to be kept in a good condition. Also, the company expects that if Pepsi is selling Pepsi, Mirinda, etc., some 10 brands, then they expect that each one of the brands should be displayed. So they expect the retailer to keep all the brands of that company and not just keep one or two, which is the high selling ones. So company has certain expectations, as I mentioned, from the retailer, and the company expects that the retailer will actually follow these expectations. They will be living up to the expectations. Now the problem. Interestingly, the companies found, or they had some idea, that the retailers are not doing what the company expected them to do. For example, the company expected them to keep only their products in the VISI cooler. However, the retailer often used to put more than just the company's product. Instead of maximizing what the company wants, the retailer was trying to maximize his own objective, that is to keep the VISI cooler full and to the maximum capacity that the VISI cooler has. So the company realized that there is a problem of the expectation that they have from the retailers, and the retailers not fulfilling those expectations. The retailers were more inclined to do what they think is the right thing, and they try to maximize the utility derived from the VISI cooler. So often they used to keep the other brands also in the VISI cooler, so that the VISI cooler is capacity is fully utilized. There was another problem, that VISI cooler was often not kept at the visible position, and it was often kept inside the shop because of electricity and other issues, and often it negated the purpose of by which the purpose the company wanted to achieve. So we found that the companies had this apprehension or some idea about this, that perhaps these retailers are not following the advice or the contract between the company and the retailer, and retailer is doing something which the companies do not expect the retailers to do. So therefore the problem with the company was to find out if this is true and to what extent it is true, and if it is true that the retailers are not following what the company wants them to follow, then what is it that can be done by the company to have this compliance. Okay, so the company made certain hypotheses. A hypothesis, as we know, is an assumption which needs testing, and the company had certain expectation from the retailers. So the cola company made a hypothesis that at least 70% of the retailers should follow the contract, which means that the cola company expected that if they had given, say, about 100 VISI coolers, 70% of those the retailers which have got these VISI coolers should be following the company's expectation, that is they should be keeping only the company's product and none of the other competing products. Then there was again a hypothesis on the proportion. So this was a hypothesis. If we convert this hypothesis into proportion, then this will mean that the proportion which will be following the company advice should be equal to or more than 70%. So this is the hypothesis that the company made. Company expected that if even 70% are not following what the company wants, then it is kind of waste of money and waste of their efforts. So they had an expectation that 30% will be the only defaulters, rest everybody will follow what the company wants them to follow. Now we come to what data should be collected to solve this problem. Now, if the company makes a hypothesis that 70% of the people are following their advice, they need to actually calculate how much percentage is following actually their advice. For this, they need to find out for knowing this percentage, they need to have some kind of a sample. So since the retailers may be running into lakhs and lakhs in a particular state or a district, so it was not possible for the company to go to almost each and every retailer. So a sampling method needs to be evolved in this case. Various methods of sampling that we have studied till now can be random sampling, but in this case the company did not follow a random sampling method because the company did not wanted to go to any shop. They wanted to go to only those retailers which have been provided VISI cooler by the company. So therefore the company already had a data of all the shops which were provided VISI cooler by this company. So they from the data that they had, they used what is called as judgmental sampling and selected a few shops from the list available, and then they went to these shopkeepers. However, there was an issue with the data collection method. If they went to the shopkeeper and the shopkeeper knows that these are the company officials which have come to know, which have come to assess whether the retailer is following their advice or not, or following the contract or not, the retailer will be more than biased to give the right answer. Because he knows the repercussions that may ensue if he is not following the company's advice. So the retailer will try to give a wrong answer and give an answer which the company expects if we ask a question regarding whether he is following the advice or not. So asking question or a questionnaire method was considered highly unsuitable in this regard, and the company people expected that if they went to the retailers and the retailers came to know about it, that itself will have a very biased results. So the company officials, instead of going themselves, they hired a market research firm in this regard, and they asked the market research firm to conduct the interview, conduct the data collection procedure in this regard. The company, the market research company also knew this fact that this might distort the data if they came to know. So they adopted what is called as disguised method of data collection. In the disguised method, the respondent is unaware that a particular type of data is being collected. So he is unaware, he does his job as a routine thing, and the data is collected without the respondent knowing that the data is being collected, because this will give us the right information and the data will be of quality. And also, instead of asking question, because the moment we ask a question, the person will have an idea as to why we are asking this question. An indirect method like observation was considered a better method. So the market research firm hired data collection people which will pose as a consumer, go to the shop which is decided through the judgment sampling method, and when they are in the shop they will observe. They will look at the VISI cooler, look at the location where the VISI cooler is kept, whether the VISI cooler is having the proper ingredients. If the VISI cooler is of say Pepsi, then whether it is having all the brands of Pepsi, and or else it is also having some other brand of say Coca-Cola or any other competitor. So they will go and simply observe while posing as a consumer, so that the retailer does not come to know about this, and the data collected in this manner will be much more reliable than if we ask a direct question from the retailer. Also, at the same time, since this study was to be conducted in a particular region, it was very important that the study gets conducted in a very short span of time. Time is important here, because if in some way or the other, if some people have an idea as to what the company is doing, then others may get alerted because of this. So therefore it was very important that simultaneously the data is collected from a large number of shops very quickly, so that there is no idea about what is it that the company is trying to do. So this was the method which was adopted: observation which was disguised. So we were observing, but at the same time the respondent was not aware of this observation. I am also reminded of that this method of disguised observation was followed by many of the great kings. If you remember, King Vikramaditya used to roam around in his kingdom at night in a disguised form, and similarly there were other kings also who used to do that, so that they come to know about the real condition of their peoples. So and this is a very good method, because the observant are ignorant of their being observed, and therefore they do what is natural to them. So it was decided that there needs to be two observations. First, because we are testing two hypotheses, so first we wanted to know, or the researchers were trying to assess, whether the cola companies are keeping only the cola company's product which has given them the VISI cooler free, and the second, they were trying to know whether the VISI cooler is kept in what location, whether it is kept outside the shop, which is the best location, or whether it is kept at the counter, which can be considered as the second best location, and third, whether it is inside the shop at a place where it is hardly visible, which is considered the worst location, and perhaps that negates the very purpose of having a VISI cooler. For analyzing this data, we require some software packages like say SPSS, Excel, Minitab, etc., and we require to code the data into numbers. For example, when we go to a shop and we see that this particular shopkeeper has kept only the company's product in the VISI cooler, then we can consider him to be following the advice. However, if you go to a shop then and we find that the person is not following the advice, we can consider him. So there are two categories of retailers: one which are following the advice, and one which are not following the advice. And if we go back to the hypothesis, the company is actually trying to see that the first category, which is following the advice, is 70% or not. So therefore, once we collect the data has to be coded, because all these software packages analyze only numbers. So whatever information or data that we collect has to be converted into some form of numerical figures. So in this case, we have coded 1 for the company products and 0 for other company products. So if we go to the first retailer and find that he is keeping only the company products, we will code him as 1, and vice versa, we will code the other type of category as 0. Similarly, for the second hypothesis of location, we can keep 1 for outside location, 2 for the next to the counter, and 3 inside the shop. So depending upon what is the actual location of the VISI cooler in the shop, we will code either 1, 2 or 3 for that particular VISI cooler location in the shop. So in this manner, we will, whatever data we will collect, we will give some coding to that data. So in this way, we know that there will be 2 categories for the first, either the person is following the advice or not keeping the company products, and in the second case there are 3 locations. So the shop, whatever shop we are visiting, we will divide the position of the VISI cooler in either first, second or third position. So coming to the first hypothesis, if we see, we find that the followers are approximately, we can say, 55%. It is certainly less than the number which the company expects, and the non-followers are again kind of 45%. So in this way, if we look at the only the descriptive also, we get an idea that followers are not equal to 70% which the company expects or more. They are less than 70%. However, hypothesis, there can be a question that may arise, that why do we then require to have any hypothesis testing in this method, in this situation? Even looking at the descriptive, we have an idea that following is around 55% and is less than 70% which the company expects. However, in statistics, we need to be sure, and we need to test this whether the 55% can be considered significantly lower than the 70% which is the hypothesis of the company. So this is the output that we get when we use SPSS. For applying binomial test, we need to go to the analyze section of SPSS and then go to non-parametric and select binomial. Why are we applying binomial in this situation? Binomial, as the name suggests, means binomial, means there are 2 situations only, yes, no, or only 2 categories of responses can be there. So in the first scenario, if you see, there can be only 2 responses. Either the person is keeping only the company products, or else not keeping the company products and keeping someone else's product also. So therefore, there are only 2 things that can happen when we visit a retailer which has been given VISI cooler, and therefore we can apply binomial. There are other conditions also which needs to be satisfied in binomial. The second condition is that the probability of success remains the same, which means that if we talk about probability, then if I ask you the question that what is the probability that the first retailer will be following the advice, so he may be either following the advice or not following the advice. There are 2 situations, and probability will be half. So if I go to the second retailer also, the probability remains half that he will be following the advice or not following the advice. So no matter whether we are going to the first or the second or the third, the probability remains the same, which is again a condition of binomial. The third situation or the third condition in binomial is that the first and any other subsequent treatment or experiment they are not related to each other. So the probability of probability of happening of the first event has nothing to do with the probability of the happening of the second event. So in this situation, we can say that whether the first retailer keeps only the company products or not the company product has got nothing to do with the second person doing it. or not. So therefore all these are independent events, and the probability of one retailer doing a particular thing does not affect the other retailers. So therefore all the conditions of binomial are satisfied here, and we can apply what is called as binomial test. Now if you look at the output, we see that the group which is following is, first of all we come to know that there are 25 observations, and in these, so we visited 25 retail outlets by the judgment sample and observed them. Out of those 25, 14 were following the advice, that means they were keeping only Pepsi products or whatever company has given the refrigerator, and 11 people were not following the advice. So we find that this proportion is 60%, which is following the advice. However, the hypothesis that we made, which is called as test proportion, was 70%. So the hypothesis that we took was 70%, but actually we observed it to be 60%. Now, when we are looking at the significance value, we find that it is more than 0.05. Hence, we cannot reject the hypothesis at 95% level. So, we will have to conclude that this proportion can be considered equal to 70%. So, although the observation is less than 70%, statistically speaking, we cannot say that it is less than 70%. So, if this is the data that we get, that the company is inclined to understand that actually 70% people are following their advice. However, in the observation it is only 60%, but yet they cannot consider that this percentage is very much lower than their hypothesis, because the hypothesis does not get rejected. However, if this hypothesis would have got rejected and the p-value would have come out to be lower than 0.05, then we would have concluded that it is very less than what the company expects, and therefore the company needs to take some corrective action. So going by this particular analysis, we have to conclude that the company does not require too much and their expectation is actually met. This also implies that although the descriptive may give a different indication, however, statistically the results may not be significant. So even if the observation is something else, but statistically they are not significant, most of the time the companies would like to take another sample and be more sure before proceeding further. So therefore, statistics is indicating that this difference can be attributed to only sampling error, and if we take another sample, then perhaps this proportion will be different, and this 60% in this case has to be considered equal to 70%. Then, as you know, that there was another hypothesis that we were trying to test. The second hypothesis that we were trying to test was that whether the location which is given, which is what the company wants, is being followed by the retailers. So the company wants the VISI coolers to be kept outside the shop. Going by the Indian circumstances, we will often find that the shopkeepers actually try to take a bit more of the space than what they are actually authorized to do. In many of the markets, it is often observed that the shopkeepers will cover a bit more than their shop's outer boundary. They will cover a bit of the common area or the foot or pavements, and will try to display many of their shop's ingredients outside the shop. This gives them a lot of advantage, because even the passerby can see those products and may get attracted. So therefore, most of the companies actually want the shopkeepers to put the VISI coolers outside their shop, so that even a passerby can look at that and may get attracted and may go for an impulse buying of these cooler drinks. However, at times in a very congested space or in certain markets, this may not be possible. So, in such circumstances, the company expects that the VISI cooler will at least be put just next to the counter. So, if somebody comes to the counter for any purpose or for buying something else, then he or she will also be able to observe the ingredients in the VISI cooler and may get attracted. So the second best location which the company expect is just inside the shop, just at the counter, and the third one is the inside the shop, which the company certainly does not like that location. And if the retailer is putting their product VISI cooler in a location which is not visible to a person even at the counter, then the entire or the very purpose of having a VISI cooler is defeated, because then it is not visible. Now, when we collected the data, it was found that approximately 30 to 33% people have kept their VISI coolers outside the shop. Around 40% have kept at the counter, and at the same time, however, 24-25% people have kept the VISI cooler inside the shop, which is kind of not visible to a passerby. Now, in order to test the hypothesis in this case, binomial cannot be applied. Binomial cannot be applied because we have got now three categories. It is not yes, no only. We have got outside shop, next to counter, or inside. So there are three categories of responses. The VISI cooler may be either outside or next to counter or inside. So therefore, since there are more than two categories of responses, we cannot have binomial in this case. However, binomial can still be applied if we club any of the two categories. So if the company expects that outside shop is the only one category, and next to counter and inside both are clubbed together as one category, then again there will be two categories and we can apply binomial in such a situation. However, if we don't want, then we can apply what is called as non-parametric chi-square test for a single sample. Very important to understand is that it is for a single sample having more than two categories, but chi-square can be applied even when there are two categories. Binomial can only be applied when there are two categories. Chi-square can be applied even when there are two categories or more than two categories. So the hypothesis in this case for the company was that at least 1/3 of the VISI coolers should be outside shop, or else we can state the hypothesis in other terms as all the three responses are equal in number. This hypothesis means that none of the responses are more or less than the other responses. If the hypothesis is accepted or is not, if we are failed to reject, then the company will be inclined to say that perhaps everybody, only 1/3 of people are following it as outside shop, and almost equal division is there in all the three responses. However, if one of the responses are very high or very low, then the hypothesis will get rejected, and then we will be inclined to say that perhaps the inside locations are very high, or what. Then we'll have to look at the descriptives to say something more than that, and some decision making will then certainly be taken by the management. Looking at the graph, it indicates that perhaps the responses are quite similar in nature. So perhaps the minimum percentage is close to 25 and the maximum going to 40. So the range is not very high, and it seems that perhaps we can consider that all the three responses are similar in nature. All the three categories are almost equal in their responses. Now, as we see, again the data is 25. Total 25 shops were visited, like in the previous case. So the data is pertaining to the same shops. The observed frequency is 8, 10 and 7. So there were 8 shops which have kept their VISI cooler outside. 10 shops out of 25 have kept it just next to the counter, and 7 out of 25 have kept it inside the shop, which was not visible even when somebody approached the counter. The expected frequency is actually our hypothesis. So our hypothesis was that all the 3 categories have equal responses. Now, what are the equal responses? 25 divided by 3 is the expectation. So 25 divided by 3 is 8.3. So we expect that 8.3 shops will be keeping their VISI cooler outside, 8.3 next to the counter, and 8.3 inside the shop. Now residual chi-square formula is sigma observed minus expected whole square upon expected. So even if you do not know the formula, but still this gives an indication that how much is the difference between observed and expected. If observed and expected have a lot of gap in them, then the hypothesis perhaps will get rejected. So if we expected the count to be say 8.3, but the count comes out to be say 18, then the chances are that 18 and 8.3 are very far from each other, and then the chances are that hypothesis will get rejected, and we'll have to believe that all categories are not equal. But if the categories, if the response observed frequency is pretty close to the expected frequency, then the hypothesis perhaps will not get rejected. So the difference between the observed and the expected is called as residual, and we are now calculating the residual. For outside shop, residual is 8 minus 8.3, which comes out to be minus 0.3. The sign of residual is also important, because this indicates whether the observed frequency is more than or less than the expected. So in outside shop, it is less than expected, a little bit less than expected. We expect 8.3, but we get 8 shops. Next to counter is more than expected. 8.3 was the expectation, but we came across 10 shops having next to the counter VISI cooler. And again, for the inside shop, it is residual is negative, minus 1.3. And instead of 8.3 as expectation, we came across only 7 shops which were having the VISI cooler inside. Now, chi-square statistics is calculated by using SPSS. So this is the SPSS output, and this indicates that the chi-square value comes out to be 0.560. Looking at the previous table, if we square this residual and divide it by expected, that means minus 0.3 square divided by 8.3, similarly 1.7 square divided by 8.3, similarly minus 1.3 square divided by 8.3. If we add all these three, then the value that we will get is 0.56. This value of chi-square is very less, and the more the chi-square value, which will be more when the observed and expected are very different from each other, then the hypothesis gets rejected. So here the observed and expected were pretty close, because of which chi-square, which is observed minus expected whole square, is also less divided by expected, and the significance comes out to be 0.756. The degree of freedom is 2. Degree of freedom is n minus 1 in this case, because if we know there are 3 categories, and if we know the characteristics, say mean of the entire data set, and we know the mean of the 2 categories, then the third is automatically determined by those 2. So we can have only 2 independent values. The third value becomes dependent on the first 2 values that we choose. So the degree of freedom is n minus 1, that is 3 minus 1, 2 category. Then significance comes out to be 0.756. Hence we are unable to reject the hypothesis, and we will have to believe that observed is equal to expected, or in other terms, all the 3 category responses are equal. This we will have to believe. However, if one responses would have come very much different from the expectation, the chi-square value will go on increasing, and then interpretation has to be made if the hypothesis gets rejected. But the hypothesis does not get rejected in this case, and the company will have to believe that the 3 responses are almost equally divided in the shops. So if there are say 1,000 shops, we can expect that say 1/3 of those shops will have the VISI coolers outside, 1/3 of the shops will perhaps have the VISI coolers just next to the shop, just next to the counter, and perhaps 1/3 of them will have VISI cooler inside the shop. Also, whenever we are doing chi-square, word of caution is very important here, that the expected frequency, which is in this case was 8.3, the expected 8.3 was the expected frequency in all the three cells. So the expected frequency should never be less than 5 in chi-square of any type. If that becomes less than 5, then the chi-square value gets inflated a bit, and it no longer remains reliable. So in order to have chi-square as a reliable method of hypothesis testing, we require that each cell must have a expected frequency of more than 5. Also, many a times in our real life situations and real life problems, we are not only interested in one variable. Often we have to come across where there are two variables, and we have to find an association between two variables. Say the two variables can be: is there an association between salary and performance? Is there an association between say gender and performance, and so on and so forth. So when there are two variables and we want to have a testing of association between these two variables, we can again use chi-square, but in this case chi-square has to be used after we do a cross-tab. Cross-tab is the short form of cross-tabulation, whereby we need to find out the joint frequency of the two variables. We will take an example in this case to understand it better. Actually, in one of my previous institute, when I was teaching, there was always a tussle between the girls and the boy students. They used to both used to claim that perhaps they perform better than the other gender. So this was a problem that came to me, and we were to take logical steps and apply some research methodology to answer this question. So the question that we wanted to answer was whether the performance and the gender was associated. That means whether the performance in any way was dependent on the gender. As we know, gender was having only two values, male and female, and performance again we measured in terms of pass and failure in the course. So we defined the performance measurement as only pass and fail and not any numbers or percentage. So here we defined that whether pass and fail, and as in the previous case, we required to do some coding. So again we had taken 25 responses which included both males and females, and we did a cross tabulation. So if you see this Excel sheet, this will be the type of data that you will come across in this case. Or else we can have another data. This is gender, and we will have the performance. Now gender can be coded as 0 and 1, 0 for say males and 1 for females. And similarly performance can be coded again as 1 or 2. 1 means pass and 2 means fail. So if you look at this, this is how the data will be entered in either SPSS or Excel. So if you look at the sixth student means 0 means female and 2 means fail. So the sixth student is a female who has failed. Similarly, if you look at the first candidate, then she is again a female, but she has passed. Similarly, if you look at the second one, this is a male who has passed. And if you look at 1 0, there is no 1 2. So if you look at the last eighth student, he is a male, but he has failed. So these are two variables, gender and performance. And before we can conclude anything about these two and apply any testing, we need to know how many of males passed, how many of males failed, how many of females passed, and how many of females failed. So suppose a large number of males passed and very few males failed, and a large number of females failed but a very few females passed, we will be inclined to say that perhaps gender has got something to do with performance and perhaps male performed better. So when we have to first do a cross tabulation as to find out how many of the combined categories are there. So when we did a cross tabulation of these 25 people, we found that 8 male passed, however 3 males failed, and out of 14 females, 6 females passed but 8 females failed. So just looking at the table, it gives some idea that the pass percentage in male was higher, 8 out of 11 passed. However, in female, the pass percentage was lower. We can say that out of 14, only 6 passed. However, is this difference significant enough? That we need to do a testing of, which can be done by using chi-square. So even looking at the descriptive, we get some idea that perhaps males have performed better and perhaps gender has got something to do with the performance. So when we do a chi-square, again the chi-square formula remains the same. It is observed minus expected whole square upon expected, and calculation is done by SPSS and other softwares, and we automatically get this kind of an output. So if you look at the chi-square value, it comes out to be 2.231, and the degree of freedom here is 1. The degree of freedom in this case of cross tabulation is calculated by row minus 1 multiplied by column minus 1. Simply means there were 2 rows and 2 columns, so 2 minus 1 is 1 and 1 into 1 is 1. So therefore degree of freedom is 1. The chi-square value comes out to be 2.231, and the asymptotic significance comes out to be 0.135. Again, since this p value or significance value is not less than 0.05, we are again unable to reject the hypothesis. So our hypothesis in this case was that there is no association between gender and performance, and since we are unable to reject this hypothesis, we will have to conclude that gender has got nothing to do with performance, and males and females, being male and female, has nothing to do with the performance in terms of pass and fail. And even if you look at one cell has an expected count less than 5, so chi-square in this case again is not reliable. The count is actually 4.84, so usually we should not have any cell having an expected count less than 5. If we take more data, then perhaps this problem of having less than 5 expected count will be countered. So we cannot take any conclusion. However, descriptive statistics indicated that perhaps males perform better than females, but hypothesis testing does not reveal that. And in today's case, in all the cases, we found that the observation may be something else looking at the data, but the company should be, the hypothesis testing tells something else, and we cannot conclude significantly, we cannot conclude with a lot of confidence that gender has anything to do with the performance in this case. So this was all regarding the chi-square testing and binomial. Just to conclude, we will like to say that today we try to adopt an approach whereby statistics was only a part, and we tried to take the problem, first explain the problem in detail, and then try to frame a hypothesis and test it through the software. So this is how the things goes, and this is non-parametric testing, binomial and chi-square cross tab for solving a business problem.
Okay, so as you said that chi-square does not signify. So what was the that was level?
That is called as significance level.
Okay.
And this significance value should be less than 0.05.
Okay, 0.05.
If this significance value or p value is not less than 0.05, we cannot reject the hypothesis. So our hypothesis was that there is no association, and since we cannot reject this, we have to believe that there is no association. If there would have been association, if this p value would have come less than 0.05, then we would have concluded that males have performed better. And then we could have, as an institute, would have done something more to perhaps do something about the girls, maybe special lectures to them, maybe more attention to them. But in this case, we cannot conclude that.
Okay. As it was, if we go through just face value, as that come from the cross tabulation.
The cross tabulation.
It was looking, it was sounding correct.
Correct.
But through this chi-square test, it is not so. How would you explain this?
Actually, we have to be very confident. In real life, we take decisions even when we are, say, only 60% confidence. Okay, so even if we are 70% confidence, we can take that decision and apply that. But in business situation, since so much of money is involved, and at times a wrong decision may result into catastrophe for the company. So the company usually sets a very high standard. Like in statistics, we have to be, say, 95% sure. At times even 99. So if you are launching a rocket in the sky, we have to be almost, say, 99.9999 kind of a percent sure. So although the relationship does exist a bit in the layman terms, but it is we are not so confident. So therefore, until unless we are that confident, we do not take any decision in statistics. So looking at the table, we get some idea, but hypothesis testing says that it's not significant. Okay. So we have to believe what the statistics says.
So, well friend, I hope you must have liked our series on a statistical tool used for the research purposes, and you must have understood in a way the resource person has intended to pass on the facts and the concept to you. So I hope this lecture must have been beneficial. So with this word I would like to conclude the lecture, and I thank all of you for watching the lecture, and on your behalf I thank Dr. S.K. Pandey for giving such a wonderful lecture. Thank you very much.